digital and progress with regards to improving healthcare through automated decisioning. I'd like to also welcome onto the line Dr. Mark Allen, who is our subject matter expert and Chief Technology Officer for Decision Management in California. Mark was the founder and CEO of Corticon Technologies, which was a decision automation software solution. Mark has extensive knowledge in the healthcare industry, being a practicing medical doctor within the U.S. healthcare industry, and has a wealth of knowledge that can be used and to gain some insight into how he used decision automation to start to drive clinical decisions, and how he sees technology being able to offer cost savings and efficiencies within healthcare and within the new world of digital healthcare. Just a quick point to note, if you wish to ask a question, we do have the ability to ask questions via the chat facility within the webinar. We've also got the ability for you to raise your hand, and we will be saving all the questions until the end. So if you want to jot down a quick note just in case you forget the question, please feel free to do that via chat, or similarly raise your hand and we'll answer the questions at the end. So with that, I'd like to pass you over to Dr. Mark Allen, and we hope you find the next 45 minutes informative and enjoyable.
Thank you, Duncan, and thank you everyone for joining. So today I'm going to talk to you about improving healthcare through automated decisioning, something that I'm very passionate about and have been doing now for, gosh, about 15 years. So would love to relay my experiences and knowledge in this area. So I'm going to first give an introduction. What do I mean by automated decision making and business rules that help to drive this? Why is this a hard thing to do? And how have we, with the Corticon solution, made this easier? And give you a vision of how this really works within the healthcare domain. I'm going to then talk about a number of success stories of how our partners are actually using Corticon to do these types of things. And then talk a little bit about what makes the Corticon product different, actually show you a demo of how you manage decision-making logic in Corticon. I think a picture's worth 1,000 words. And then sum it up and go to questions and answers. So automated decisioning is software that helps to make the right decision at the right time, instantaneously at the point of need, and with agility, with the ability to change how we make those decisions. Now, what do I mean by decisions? An example is, what diagnostic tests should we order based upon the information that we have right now on this patient? When should we alert a physician before monitoring a patient's data? And is this prescription accurate? Is there potentially a problem? Is there a better prescription that this patient should have? So all of these decisions are governed by hundreds or even thousands of individual business rules that may come from clinical practice guidelines or some combination of knowledge of your doctor and those clinical practice guidelines. So the example of what diagnostic test should we order might have an example of one business rule being patients with cough and a fever should get an X-ray. Of course, there are many, many other business rules that would interact with that rule to determine the appropriate action. Now, a business rules management system, also known as a rules engine, is software that's used to manage this type of logic and externalize it from the rest of the application logic. Now, what's key here is that it allows business people, subject matter experts, doctors in this case, to manage the logic not as programming code, but as business rules that they understand. Now, you still have the system of record, in this case, an electronic patient record. At the point in time, though, that you need to make a decision, instead of just giving a set of orders and allowing the doctor to choose which orders to make, instead a rule engine runs in the background and makes a suggestion to the doctor. Make sure that you order this. You don't need to order that. And if the doctor wants to understand why, they can look at an audit trail of exactly what rules fired in what order and how those rules tie back to the clinical practice guidelines themselves. Now, before I started Corticon, I was trying to build these types of systems, clinical decision support systems. And I, over many, many years, was banging my head because it was so difficult to manage this type of logic. Now, if you've got a good team of programmers and you give them, let's say, the clinical practice guideline and give them many months, they'll come back and be able to implement that into the system. But in my case, when I did that and the programmers gave me the system back, I plugged in a few patient cases and I found errors. Why? Well, because it's very difficult to understand the interrelationships of the rules, and the specification of the rules, in the case I was using clinical practice guidelines, is ambiguous and incomplete. It's enough for a physician to use that to make decisions, but when you try to automate that logic, it has holes in it, which are effectively bugs in your system. So I took many years to really dive into this problem. How can we understand the interrelationships of this logic? How can we represent it in a form that the doctors can actually understand where the errors are and make changes more easily? So really key, and that's really what made Corticon. Now, the issue is that the rules change all the time. So in clinical practice guidelines, the clinical practice guideline can change. Well, a hospital policy could change, consumer preference, a regulation, new technology, market shifts. All of these changes using traditional ways of automating business rules require massive changes to our system. So literally changes that doctors can describe to one another in a matter of minutes can take man-months to change when you have thousands of rules in that system. So this is why we developed Corticon. So let's kind of describe Corticon. So first, we help to separate the decision logic from the rest of the code. And we empower subject matter experts to manage those business rules with integrity. Actually get out the errors in the logic themselves. Understand that for this given decision, they have complete logic, that their logic's not conflicting, that it can never go into a circular loop and not return a response. This concept is, for those technical folks out there, is as important as the concept of referential data integrity is for the database world. So before referential data integrity, it was very easy to get garbage data into a database. Likewise, without referential rule integrity, it's very easy to get garbage rules into your rule base that break that rule base. Corticon is unique in solving this problem. So next, the rules themselves using Corticon are directly executable. Corticon compiles those rules into the most efficient executable code possible, as if the world's best programmers were to program that into incredibly efficient code. That's what the machinery of Corticon does. And it exposes those rules using open standards, web services, REST services, Java, .NET, so that any application can call those services. So whether it's your electronic patient record, calling directly from a database, or any other system, very easy to call Corticon. And the performance is optimized and can scale to handle millions of decisions per second. So last, or next, also Corticon can integrate and pull data from a variety of different data sources. So whether that be patient data, lab data, any data sources Corticon can easily pull from as part of its decision making. Now last point here is that rules change. So when those rules change, you need to very easily understand the impact of that change. When I make a change, what other rules are impacted in ways that the decision modelers, the subject matter experts, can easily understand. Now, a vision for for healthcare here, this is the traditional model that we're in today. So patients are interfacing with the healthcare providers. The healthcare providers have electronic patient records to store that patient data. Well, things are changing very rapidly. So the patients themselves now are very well informed. They have websites that they can look up. They've got smartphones. They've got health devices that they're wearing that are tracking their healthcare. And healthcare providers also have access. They're starting to carry around tablets that can interface as well. So how do we use these new technologies to our advantage in healthcare? Well, of course, the use of a BRMS is very key in this capability. So a BRMS can monitor the data that comes from a patient, directly from a patient, that comes from the electronic patient record, that comes from other sources, lab data, for example, monitor data. And when it identifies patterns to make decisions upon, it can alert the physicians, it can alert the patients, it can alert other healthcare workers. Now, ultimately, what this does is drive down the need for the encounters directly between the patients and healthcare providers, because actually the patient's having far more encounters with the healthcare system through the automated decisioning in the BRMS. Now, this can provide a number of benefits according to our experience. So improved compliance from the patient, improved outcomes, decreased utilization of the healthcare system and associated costs, and greater patient satisfaction. The patient feels more in touch with the healthcare system and healthcare providers using these types of technologies. So let's talk about some success in healthcare. Now, important to note here, while Corticon got its start in clinical decision support, we expanded very quickly into a variety of other industries. So Corticon is very successful in insurance, financial services, government, health and human services, in government, e-commerce and retail. So lots of different examples. I'm going to focus for the purpose of this presentation specifically on the healthcare examples. So first of all, in terms of providers, so I mentioned in some of my use cases clinical decision support, and clinical decision support can be provided in a number of places, directly at the point of care, directly to the patient, through call center guidance and automation, through triage and scheduling capabilities, so lots of capabilities there. Disease management, we're seeing some applications in terms of monitoring the patient population, providing some guidance and outreach to patients, giving patients their own capability for self-care advice. Clinical trials and grants management, so we have applications here in terms of certification, registration, coding guidance, data validation, lots of business rules go into clinical trials, and also the application of grants. Billing and claims, so a key area here for us, lots of clients using this for pre-authorization to make sure that they can bill for something they're going to use on a patient. Invoice optimization and what they term revenue cycle management is another key area that many clients are using Corticon. So supply chain management, so helping with optimizing purchasing, inventory management, logistics within their supply chain. And last is resource utilization, so scheduling of resources more optimally, or managing resources such as helping to move patients through the hospital and make sure that we're doing the things that are necessary to free up the bed if we need to for those next patients. So you can see lots of different applications for this common automated decisioning technology. Now diving into clinical decision support, again, lots of places to apply rules against many different data sources. And lots of opportunity here to personalize the patient plans, improve the outcomes as we've described. Lots of administrative benefits and accuracy of diagnosis and reducing costs. So let's jump into a few examples of how our clients are using Corticon. So this first example is a solution that CSC, a global system integrator, has built, and we've deployed at Kansas University Medical Center in the middle of the U.S. So this solution does a few things. So the first of all is it monitors patient data to identify when a patient is at risk. And their focus are the kinds of things that are hospital acquired. So deep venous thrombosis, pulmonary embolism, sepsis, things like that. And when it identifies, by monitoring the patient data, a patient at risk, then it notifies the healthcare workers. Specifically, it notifies a nurse on staff at the hospital who can then notify the physician. And what we found in testing is that this Corticon solution is able to identify patients at risk for sepsis a full 24 hours earlier than the physicians without the system. Now, in addition to this, it also helps with reporting. There are a number of reporting requirements in the U.S. that help to increase the level of reimbursement from the U.S. government. And this system helps with that reporting as well. So next, a customer in the United States, Boston Heart Diagnosis, uses Corticon to provide personalized therapeutic plans to patients. So very key capability here. Before they were using Corticon, they were manually managing their rules, and they found that they just couldn't keep up with the pace of change. And now using Corticon, they're able to keep up with the pace of change and allow their subject matter experts to manage those rules directly. Next is VitalBox. VitalBox is a company out of Brazil, and a very interesting application that they call the Personal Health Platform. And it calculates patients' risks of developing various chronic conditions and proposes various actions to reduce those risks, selling this in partnership with health insurers. And a number of benefits that they've provided. So again, they were trying to do this by manually managing the rules, programming those rules, and just couldn't keep up with the pace of change. So things that took 6 hours to develop took only 10 minutes to manage in Corticon. So really significant difference. And this helped them to scale their application and ultimately scale their number of users. Very quickly, I might add. Another customer in Europe is the Romanian government. The Romanian government approached us because they had a problem with prescription management, both with fraud in prescriptions. They had more people sign prescriptions in Romania than there were people in the population. So obvious fraud there. And also with the desire to reduce medical errors. So working with the system integrator, HP Enterprise Services, we delivered to them a system that managed the prescriptions in an electronic form. So I'm going to walk through some of the aspects of this because there's an amazing amount of complexity here. So there's a lot of data that comes into making this decision. So the medical history that comes from the electronic patient record, the current assessment of what's going on with the patient. Corticon actually hits a drug-drug database to determine the existing interactions between drugs. So that database is managed externally to Corticon, but Corticon compares the patient data with the prescription data with that database to determine if there's a potential problem. And if there is, comes back and makes an alternative recommendation for this particular patient. And at the same time, it's able to look and identify for fraud. So talking about HP, we've done a number of solutions with HP as a solution provider who's standardized on Corticon across a number of applications, both in healthcare and beyond. So some of those applications, just to mention, they have a system that manages and administers the Medicaid benefits. So this is basically a claim system, also registers physicians. Now Medicaid is the health insurance program government-sponsored for low-income people in the United States. And HP manages about 50% of all patients in the U.S. under Medicaid. So there's a similar system that they sell to commercial insurers called Medavance that Corticon's a part of. Corticon's a part of this electronic prescription system that I mentioned that's been sold to a number of different places in addition to Romania. They also use Corticon as part of a care management system and as part of needs assessment inside of a Medicare system, and also use it to determine eligibility for Medicaid. So you can see a number of different applications that they use Corticon for. So in the area of health and human services in the U.S., Corticon has quite a footprint. It's actually 25 now. We just won with Oregon very recently, and lots of success stories. So it's what we've been doing recently in the United States is implementing some massive changes in regulation, commonly known as Obamacare, the Affordable Care Act, which changes the health care insurance in the U.S., really broadening the coverage for a number of different parts of the population and regulating other parts of the population. So Corticon has been the #1 rules engine used by states for this purpose. And an interesting thing here is that the states are sharing the business rules in Corticon from state to state. So Corticon is very unique in its ability to manage its rules independent of the implementation and to be able to share those rules as standard models that I'm actually going to show to you and implement those models in a number of different technical architectures. So another customer to share, Benue Pharmacies, part of the Brokasef group. I was just out visiting them a couple of weeks ago in the Netherlands. Really exciting customer use case. Very large pharmaceutical supplier in the Netherlands and expanding to other parts of Europe. They manage about 500 pharmacies, 100,000 different products, and they have 40 health insurance partners. So the first problem that they tackled with Corticon was pricing. So pricing of the pharmaceuticals. So complex problem, and those prices need to be updated on a regular basis, and commonly new products come out and new contracts with the health insurance partners. And so they were managing the pricing before using Excel spreadsheets, taking a lot of time to do this. They put all that pricing in Corticon and found that it's much easier to manage pricing, to do what-if analysis of pricing, much more transparent pricing. And the same financial controller that was managing those spreadsheets with a lot of help from programming is now managing those rules in Corticon. So that was the first application that they did. Second application they did was to look at, are there opportunities to optimize profit by swapping out different products. So an example would be, well, this particular prescription that we have, instead we could swap out this particular product for another generic that makes us more money under this particular contract. So all of this is done in ways that assure contract compliance. Now the last application that they did, which was very interesting, they're working on now, is clinical recommendations. And they had a number of clinical recommendations already in their system. So an example of a clinical recommendation would be if a patient's been on an NSAID like ibuprofen for a couple of months, then recommend to the healthcare provider that that patient also be put on a stomach protective agent. Now, those types of clinical recommendations took a long time to build. They were building them in Java before using Corticon. And when they converted one of them, they did a test and shared with us the results. That one that took 4 days to build in Java took only 1.5 hours to build in Corticon. So you see how they can do much more with the same number of people and build a much more compelling application using Corticon. So that describes, I think, a number of different use cases, and I could go on for days. I love those different use cases, so much more than I ever imagined when I started Corticon. So let's talk a little bit now about what makes Corticon different. So Corticon is recognized as a leader in the field of business rules management, rules engines, but also is recognized as breakthrough. That's a big term for analysts. So breakthrough in terms of ease of use for business analysts, and breakthrough in terms of solving the integrity and performance problems inherent in rules engines, according to analysis by IDC. So that really summarizes the key points of differentiation. So number one is the easiest product to use. So lots of different rule engines out there, rule engines that are built into electronic patient records, allow you to manage simple rules using a business interface. But as soon as you want to do something complex, and by complex I mean goes across a variety of different interrelated data, as soon as you want to write a rule like that, well then it requires programming. Only Corticon allows you to manage even the most complex rules without programming. Second, it's the most reliable, so I've touched on that. Only Corticon has features that guarantee the integrity of the rules. And this allows your business to make changes to that rule base and ensure that it won't break the system. And last, Corticon is the fastest rule engine on the market. So other rule engines that can solve complex decisioning problems have scalability issues, specifically when it comes to increasing amounts of data that's being processed. Well, in things like clinical decisions, where you need to process a lot of patient data to make a decision, those rule engines can take minutes to return a response. So Corticon is uniquely scalable with our patented rule engine in addressing high data-intensive problems. So let's actually show you Corticon. Now, working with Corticon, you always identify what decision are you trying to make. And then you gather the rules associated with that decision, or the policies or guidelines that document those rules, and then you begin modeling those rules in Corticon. So to demonstrate Corticon, I'm going to show you a very trivial example of somebody applying for life insurance. Now, this example is very trivialized to really show you the key concepts of how to manage rules in Corticon. I'm going to show you an example after I do this of a more complex example, but bear with me as I show you the key concepts of the product. So breaking apart the process of processing an application for insurance, we would break that apart into a few different steps. So once we receive the application, we validate the information, we determine the risk profile based on that information, we calculate the premium based on the risk profile, and then we route for approval before we send back the quote. Now let's focus on this decision, determining risk profile. So how do we make this decision? To get the answer to that, we have to ask the people that perform or manage this particular step in the process. So let's suppose that we ask our subject matter experts, and they come back with two simple business rules. They say, oh, it's really simple. If an applicant's a skydiver, they're high risk, and if an applicant's under 35, then they're low risk. Now what we do is we take these rules and we model them in Corticon. So I'm going to switch over to Corticon Studio and show you how we model these rules. So first of all, to orient you to the product, down here is the rules exactly as the business expresses them, what we call the rule statements. Up here is where we model the formal expressions. We put the conditions of the rules in this section, we put the actions in this section, and we tie together the conditions and the actions with each column. Now, in order to model the rules, we need what we call the rule vocabulary, which are simply the terms that are referenced by our rule statements. So things like applicants that have age values and skydiver values and relate to one or more policies. Now, how did I get the vocabulary? Well, if you have existing systems, Corticon can reverse engineer automatically and import in vocabularies based upon databases or class diagrams, object models, things like that. Or if you're in a pure modeling mode, you can build your vocabulary right here in Corticon on the fly. Now, let's model this first rule. The first rule says, if an applicant's a skydiver, that's my condition, then assign high risk to the rating. So I'm going to come over here and I'm going to drag and drop applicant skydiver. And for my first condition, I say, if skydiver is true, then assign to the risk rating the value of high. This implements my first rule statement, so I'll note this, that now this rule statement is tied to that column. So that was very easy. Let's go ahead and do the second rule statement. The second rule statement is talking about an applicant's age. In this case, if the age is less than 35, then assign a low risk rating. This implements my second rule statement. So now, this is the equivalent of having to write an if-then control structure in a programming language. Obviously a lot faster and a lot easier and a lot more accessible. We'll go ahead and save this. We now call it a decision service, and go ahead and test this decision service. This is how we test. Now we can import in existing data if we're tied to a database, or we can drag and drop from the vocabulary and create our own, which I'm going to do here. So I'm going to call this first applicant Tom. Give Tom an age of 30 and make Tom not a skydiver. So we would expect that applicants less than 35 should receive a low risk rating, and we'll see what happens. We'll run this test, and the first time it compiles the rules down to an executable and should give us a response. For some reason my computer is very slow because it's, I think, loading this the first time. There we go. Okay, we see that the risk rating was assigned low, and we see down here the audit trail of exactly what rule fired. So it's working just great. Let's create a couple of additional examples. I'm just going to copy and paste Tom, make it his friends, Tom, Dick, and Harry. Now for Dick, we're going to give him a skydiver value of true. So Dick's a skydiver, so applicants who skydive should receive a high risk rating. And Harry will make an older gentleman and see what happens with Harry. So now we'll fire all three simultaneously. And you see it was almost instantaneously once the rules were loaded into the engine. So no change in Tom. But look at Dick. Dick's a skydiver, but Dick received a low risk rating. What happened here? Well, if we look at the audit trail, we see that both rules fired. So first he matched for skydiver and was given a high risk rating. Then he matched for age and was given a low risk rating. Was this the intent of the business? Probably not. What this illustrates here is a case of conflict in our rules. We only have two simple rules, but we already have a case where our rules conflict. What happens when we have 100 rules? Now, while Corticon has a cool testing tool, testing is the wrong way to identify logical errors. Why? Because as your rules grow in complexity, it becomes an intractable problem. You don't have enough time to test all possible logical scenarios. So in a moment, I'm going to show you a much better way to identify those logical problems. But first, let's look at Harry. What happened with Harry? Well, Harry doesn't have a rating. Why is that? Well, we have a rule that says if an applicant's less than 35. We have a rule that says if an applicant's a skydiver, but we don't have a rule that matches the other set of data. So this we would call a loophole in our policy. Now, I can tell you, working with the most respected physician organizations and their clinical practice guidelines, or some of the world's largest government organizations and their legislation, or the business policies of the world's most respected organizations, that those forms of rules always have logical errors in them. They're incomplete in their specification. They're ambiguous in their specification. Why? Because language itself, whoop, I am sorry. I'm back. Okay. Language itself, English language, French language, whatever language, is informal. It's not a logically formal language. We need to formalize this logic in order to get out the errors. So what I'm going to do is I'm going to define what my expected results would be. So for this second applicant, I'm going to say that I would expect here a high risk, regardless of the age. And for the third one, I would expect medium for somebody who's not a skydiver and older. So now I'm going to run all three simultaneously. And I see now that Corticon points out where those errors are. So now let's go back to our rule sheet model representation and show you how to identify these logical errors up front. So this first rule says, if an applicant's a skydiver, they're high risk. The dash means I don't care about age. But if I double click this, Corticon knows that there are only two allowable ranges for age, and both are high risk. Likewise, for age less than 35, a skydiver or not, that's low risk. So now let me collapse these back down and show you these features that guarantee the integrity of our rules. This first one says check for conflicts. So I click on it and it highlights my rules in red. Now if I expand these rules out, Corticon shows me in the precise scenario of a skydiver less than 35, you have a problem. So now let me collapse these rules back down and address this problem. The right rules should be, if the applicant is a skydiver, regardless of age, Rule 1 should override Rule 2. Now if I check for conflicts, there are none. Next is check for completeness. I click on this, and Corticon Studio comes back and says, hey, you forgot about this last scenario when somebody's not a skydiver and older than 35. Well, what do you want to do? We want to make this a medium risk. We're going to add in a third rule statement here. We're going to post this rule statement to the applicant themselves. For the sake of time, I'll just type in medium risk here. Last is I'm going to check for circular logic, logical loops. This is a very simple set of rules. There's no circular logic. So now I'm going to save this rule set that now has integrity, go back to my same test case, and run the same data through the new rules, and now I should see a very different response. Every time that you make a change to the rules, those new rules need to be compiled down into an executable, which can be done before they're put on the server. So this can be much faster to execute itself. Now we see here that no change in Tom. Dick is now high risk and only the appropriate rule fired, and Harry now has a risk. So this is the gist of Corticon. Now this example, as I mentioned, is trivialized. I'm going to show you a real-world example where this came from. Now, a real example might be much more complicated, might involve multiple different steps, many different criteria that we're making a decision based upon. And this particular example, I'm having some trouble with my computer right now, so I'm not going to show this example because I'm going to go back to the slides and go into the rest of the slides. For some reason, I'm having a little bit of trouble here with the demo. So I think you got the idea, though, and let me say that this very simple modeling approach scales to handle even the most complex decision-making problems. And we'd love to work with you on any problems that you might be interested, or take some time to show you lots of different examples that we might have. So this next slide shows how this might come together within the context of a web page or a mobile application. So it's very easy using tools from Progress Software or tools from anyone else to build a web page that can make a call to a Corticon decision service. So as I mentioned, the decision service is simply represented as a standards-based interface. So in this particular web page, we could fill out some application, hit a submit button, and when I hit that submit button, actually make a call via a web service or a REST service to Corticon and provide back the result and display the result in any way we might be interested in doing. That shows how it might come together within an actual application. Okay, so let's summarize now. So we've seen across many customers a lot of these different types of benefits. So reduction in cost. Some of the early applications that I did showed a 50% improvement in clinician productivity, half the time it took them when they used the decision support technology. We saw a 30% reduction overall in tests and treatments. So we actually saw an increase in the right tests and treatments, but a reduction in the wrong tests and treatments. And this may play out more significantly in the U.S. because doctors, it doesn't cost them anything to order an extra test and treatment. But if they don't order the right test and treatment, they could be sued. So we found that when they had the decision support, it helped them to make the right decision and order only the necessary tests and treatments. Of course, this was a massive improvement in quality that we found. And this type of application really can't happen without a strong rules engine. You can't manage this type of logic using traditional programming techniques. And even if you're using the built-in decision support that exists within an application, well, if you get beyond what that application was meant to do, then you need to program. And last, a BRMS is excellent for proving compliance. If you ever want to know why the system made the decision it did, all you have to do is look at the audit trail of exactly what rules fired, which can tie back to the guidelines and people that actually recommended those rules themselves. So I know that there are a few solution providers in the audience, and like the example of HP, we work very well with other companies. We'll really provide a very strong tool set, effectively the brains of an application. But we really need to partner with others to deliver complete solutions. So whether those be solutions like the CSC solutions or the HP solutions that I mentioned, or lots of other types of applications, we'd love to work with you to help to deliver more value to your clients. We can help you to build demonstrable applications, show how to build Corticon in your application. And as I mentioned, the Corticon is incredibly easy to learn how to use. We can get new people up to speed on Corticon in a matter of a few days via our online training capabilities. Now, any of you who are interested in learning more about Corticon, you can evaluate it. The software is available for download. It just takes a few minutes to sign up, download, and install the software. Runs on any Windows machine, and it runs either as a standalone application or as a plugin to Eclipse. So with that, I want to thank you all very much for your time and open it up to some questions.
Mark, thank you very much for that. That was extremely interesting and started to really provoke some ideas. We have got a couple of questions in chat. We are just trying to expand the chat window here. And while Nick's doing that, I was just going to pose a quick question with regard to what are your thoughts on things like the wearables discussion? I know you covered it in a slide earlier where we're starting to see those start to take some more role in people monitoring themselves. Obviously you see Corticon being able to provide a benefit to that. Is there quick and easy ways of being able to integrate Corticon with other systems potentially, so that people can start using this technology easily and integrate it with apps?
Yeah, so what the wearables do is provide a lot more data. Now that data can be viewed by the patients, and that's always interesting. Or you can analyze that data and actually make recommendations based upon that data and the unique aspects of the person themselves. So what are the person's goals? What is the person's medical history? What is the recommendations of the physician? So yes, Corticon is quite easy to integrate into those types of systems. So Corticon can be deployed into cloud environments and used to analyze that data and actually make decisions and recommendations right back into the apps themselves.
Excellent. We've also got a question from Sudhir Krish here, and it says, do you have content, i.e. rules, relevant to healthcare, or do we need to come up with rules ourselves?
So the answer to that is we at Progress do not manage and maintain the content. We're not the subject matter experts in any one of these domains. We're the subject matter experts in Corticon, and so we can provide you a library of examples that are really demonstrable actually hundreds of examples that we provide to our community in our library, but they're not examples that you want to use in production. They're more examples of how do you do clinical decision support, how do you do eligibility systems, how do you do pricing types of logic, how do you do optimization. We've got a Sudoku solver, a traveling salesman types of problems. So we have lots of those types of examples, scheduling problems, but we do not maintain the logic. Now, we partner with others that maintain the logic. So the examples that I gave you, CSC maintains rules in Corticon, HP maintains rules in Corticon, Deloitte Consulting maintains the Obamacare rules in Corticon, those types of things. So that's really what we rely on our partners for, is to maintain those rules. In the case of some of the things that we're doing in health and human services, those rules are actually shared directly between clients as well.
Excellent. And as a follow-up, Mark, from an e-prescribing perspective, do you have any sort of feeling of how long it took some of the e-prescribing, so specifically the Brocacept example, how long it took them to get them up to speed?
Well, Brocacept isn't doing electronic prescriptions per se. The electronic prescription example that I gave you in the Romania, there's also several states in the U.S. that are using that type of solution. So the first time that solution was built and integrated, I think it's First Data that provides the drug-drug interactions there. That took a while. Maybe 6 months for the initial development. Now it can be rolled out much quicker. So it can literally be a matter of plugging that into an existing infrastructure. So whatever the integration of the system, the application's already built. Now that application is built for the U.S. It's built for Romania, so it may need to be customized to the needs of a unique government and pharmaceutical supply in that country.
Okay, well that's all the questions that we have at this point in time. So I would just like to draw this webinar to a close. Mark, thank you very much for a really interesting insight of how Corticon can be used in the healthcare industry and in the new digital age of smartphones and devices. We're obviously going to make this webinar available for download should you wish to go back and listen to any certain points again, but I'd like to thank everybody again for their time, and hopefully we'll see you all again soon.
Thank you all very much, and have a great day.